The particular things I like about this XL4016 buck converter is its 3-leg LED. It's a multicolor LED. When there is a flow of current, it turns red, otherwise it remains blue always. So this is the very interesting thing. Let's apply this feature to a simple battery charging circuit. Here are some different kinds of LED: 2-leg, 3-leg and 4-leg. The most common part is its long pin. Its long pin is either a cathode or anode. You have to find it manually. Here in this 3-leg LED, the common pin is cathode, and in 4-leg LED, the common pin is anode. In this 3-leg LED, I connected most common long pin to the cathode side via a 1K resistor and test the anode side of two different parts, whether it is red or whether it is green. Here it is green and it is red. Similarly, in this 4-leg LED, the common pin is anode. I connected it via 1K resistor and test it with the different cathode side, whether it is red, whether it is green or it is blue. Here I use a 3-leg LED in this battery charging DC power supply. When the battery is connected to the source, the LED turns red. When you turn on this power supply and increase the DC voltage, slowly the LED turns green. It means the battery is charging. When the battery is fully charged, it will automatically, the LED will turn red and the current does not flow. When the indicator is in red, it means the battery is not charging. Let's execute this process with the help of a breadboard, and we need three things. The first is a 3-leg LED, the second is a 1K resistor, and the third is any kind of diode, whether it is 3 amp, 6 amp or 1 amp according to your load. Source and here is your battery to charge. And here is your 3-leg LED. The long pin is the cathode. Add a 1K resistor in the way. Let's connect to the plus. Connect it to the battery. When the battery will charge, the LED will turn green, and when the battery will not charge, the LED will turn red, green and red. Here is some advantage and disadvantage for using this technique. First, the con side. Due to this using of this diode, there is always a voltage drop of 0.7 volt, and there are some benefit also. The positive side is it acts as a reverse voltage protection. When there is a failure of power supply and the battery is somewhat charged, the current will not again flow to the source. It is a good point, and another point is there no need the use of multimeter always to measure the charging voltage of the battery. You have to just make sure the LED is turns green while charging. Here is the diagram of the circuit. If you want to use, you can take the screenshot. Thank you.